The first step is always identifying some sort of physical connection point for the machine. Oftentimes, this is some sort of Ethernet LAN port, but can also be other things like an RS-232 port to communicate over serial. From there, you're going to want to go on to the equipment and actually identify any software that's running there. In this case, we have a TwinCAT 2 Beckhoff PLC running on top of this industrial PC. From there, I'll open up my Claude or ChatGPT terminal, and I'll actually start planning out how I'm going to write the transformer utilizing FlexCore. Some tips here. I normally will use Claude, and I'll actually run this directly inside of a shell that is pointing at our open source transformers repo. This gives it basically all the context necessary to write the software. But from there, in the planning mode feature of Claude, you really want to give Claude as much context as possible about the target machine for the connector. So in this case, I'm giving it some information about the Holzman saw, about the TwinCAT system that's running on there. And this is normally a multi-step process in terms of interacting with the AI to get it up to speed, and it's only going to help with debugging later on in later steps. I do also definitely recommend exploring multiple possibilities of different approaches. You don't want to get stuck into kind of one approach and then not be able to pivot from there. But once Claude understands that full context of the connector that you're trying to build, it can actually generate the code directly into the transformer repo. So it'll generate the Python and JSON configuration files necessary in order to just directly plug into FlexCore. So it actually completely understands all the methods it needs. It understands the files it needs. So here we're just showing, that exact code that was output from that Claude session. We can actually go in here and directly import the transformer into the FlexCore runtime environment. What this is going to do is basically create a mirror of, what you generated in the Claude session with, the actual runtime environment. And it gives you an editable, field here. It's just basically a VS Code editor directly in the browser where you can do things like save it, directly hot reload. So as you're testing, it's actually reinstantiating the driver in real time. This is just showing kind of how you formalize a transformer into an actual device within the system where it's utilizing the JSON files that get generated to generate some fields that get filled out when you import. Once you have that set up, you can actually use the FlexCore API. This is at flexcore.app.local 7081/API. So those endpoints that Claude wrote, we can actually test these. We can look at errors. We can feed that back into our Claude session, from there, and make edits, as errors are occurring. And once all this is said and done, you'll have a fully functional connector. Typically, this process takes less than 1 day, which is extremely efficient compared to the weeks that can take to build connector drivers for various systems. So it definitely speeds up our overall process while we're doing on-site implementation.